Yeah, right now. Okay, your turn.
Okay, thank you. First of all, I just want to say thank you to Jorge. He's been very patient with me. We've been going back and forth, setting up this meetup. The reason why I want to do this meetup is I want to share the experience and so also the knowledge that I've gathered for so long in Android development and also pretty much in the Android space to share with other people around the world. So I've done this kind of virtual meetup before in Japan. So this is my second one virtually uh, for you guys. So hopefully, with this from this presentation, you can learn something. And if not, well, at least we have met virtually. So let me start by sharing my screen. So let me know if you can see or not. Okay. Okay. You can see my screen now.
No.
No. Okay.
Yeah, right now. Yeah.
Okay. Cool. All right. So the topic that I'm going to talk about right now is about learning and building AOSP. AOSP is basically is the Android open source project that is basically the whole Android operating system that's running on your device. So if you're using Android devices, may that be a tablet, may that be a phone or Android TV or whatever it is, that is basically based on the AOSP source code that's available from Google. Um, so just want to give you a bit introduction about myself. I'm working as a senior Android platform engineer at a company in here in Australia called Blocks Global. They are based in Melbourne, and I'm based in Sydney. I've been working with them for the last, I think so, for the last 4.5 years now. Um, and I've done review two Android book review, the Android system programming and then expert Android programming. So if you're interested in the system programming itself, which I'm going to talk about today, this is one of the book that you can read. I've also done, I've contributed Android articles pretty much on the internals of Androids for an open source magazine called magazine.android.com. So if you want to download the magazine, it's free of charge. You can download it from this website. So they've been publishing this magazine for the last, I think, so 4 years also now. And if I don't play soccer, I'm a big Barcelona fan, including my son. I do contribute to the AOSP project now and then when I'm not lazy also. So that's a bit about myself. This is the two product that I've built from scratch. Basically, what I mean by from scratch is basically I've taken the Android source code and customized that to use for our product itself. So pretty much you can say that we are very mini Google because we do everything ourselves. We support the product ourselves. We customize the Android product, the Android open source project, and then we develop our own apps. Everything from the infrastructures and everything we do ourselves. So this is the two different products that I've built ever since I joined the company. The first one, the mydomain.org product, is a product for the aged care market. So if you have a relative or your parents in the aged care environment, and then they want to use a device or want to stay in touch with the family, this is where the market is. The screener.digital is basically it's an advertising product. It's used for in the advertising space. So we're running content 24/7, and it's all powered by Android. So we customize everything ourselves, including the browser that's running inside the product itself. So why you must be asking a question, why do I need to know about this AOSP? What's so important about it? I'm just an Android developer, so why do I need it? That's those are the question that I get from Android developers. But sometimes when you write application, you tend to ask this kind of question, why, how, where, when, you just want to know what's going on, underneath, how does this work? How does my application interact with the hardware, for example? How does my application communicate to the network, that kind of thing? And where is the code, where is my data being stored? I mean, like nowadays you want to know about, you are very conscious about your privacy. You want to know, where is my data? Where is it stored inside the device, because I want to save my data also down the track if something goes wrong with my phone, for example. And then sometimes when you run an application, you don't know, all of a sudden you have a crash, but you don't know what happened. How do I troubleshoot that kind of thing? And then when does it run? When does it stop? Sometimes you get a situation where you write a service based application and then the service doesn't run. Why is that? Why does it crash, for example? Why does it run after X number of time after it crashed? That kind of question. So these are the questions that hopefully, if you look at the Android code down the track, you will find this kind of answer. It's not going to be a easy kind of answer to find, but at least it will give you the pathway where you have to go, basically. So let's think about the Android as a product itself, right? So Android is a very complex product. Internally, it's a very, very complex product internally. Now, it is like a jigsaw puzzle, or it's like a Lego set where you just try to join everything together and make it work. That's how it is built, basically. So there's a lot of parts also inside Android as a product. So you might be writing an application, which is a very simple application, for example, like a game or something like that. But the interaction that happened between your application all the way into the hardware, that's a very long path down there. But it's very fast. That's thanks to the microprocessor. That's why it's very fast. You don't see any lagging. You don't see any slow in your application. You don't see any, when you watch video, you don't see any jank, that kind of thing. But internally, it is very, very complex piece of software, as there's a lot of moving parts, but they are able to seamlessly work together in harmony. You do sometimes, if you've been using Android for quite some time, you do remember back in the olden days also, you find things are not working properly and things like that. That's because there's a lot of moving parts, and sometimes you do get this kind of bugs now and then that needs to be updated, that needs to be fixed. And that's where sometimes you get updates and things like that for your phone from your vendor, basically. So just to give you an idea that the internet itself, how complex it is. Now, most of us are very familiar with the device that we're using, right? So we're using device like phone and tablets. That's predominantly where the Android space are. Most of the time, people are using this kind of devices. Now, what is interesting is actually there's only two silicon vendor in the world that provide this. Actually, there are smaller one, but the predominantly one is the ARM and the Intel. Now, the device that normally are used for consumer product like phones and tablets, they are basically running the ARM processor. So it can be from a company like Qualcomm, it can be from a company like MediaTek. That's why you will see a range of prices for phone from $50 all the way to $1,000 and things like that. That's because you have so many silicon vendors there in the ARM space that they can provide you different kind of price range. In the Intel space, most of the product are not in the phone or tablet. That's mostly in the TV box, or like mostly in the kind of a customized kind of environment. Like one of the product that we are selling, which is the screener product, that's running an Intel processor. So Android actually does run on Intel platform also. So if you have a computer at home, which is an old computer that you're not using or things like that can run Android as a desktop environment. So you can use that as an alternative kind of operating system. So that's the two pretty much dominant silicon vendor out there that's running Android as a platform. We'll take a look at both of this. I'm going to show you later on also the master branch of Android operating system, which is basically the latest and greatest code that Google keep on working on that, and also the Intel version. There's not much different in terms of the software support, but the sad reality is the Android in the Intel space are being maintained predominantly by the open source community. So that's why you have an Android x86 project, which is basically run by the community itself. Okay, so what I'm showing here is the Android architecture. Now, most of the time, most of the Android developer will be running. Can you see my mouse?
Yeah.
Okay. Most of the Android developers like you guys, most of you are writing this part over here, the blue part here, which is the application. Here is written system application, but this is all application that's running. So if you have YouTube, you have Gmail, you have Instagram, all this kind of application, this is the layer that is running, right? So this is a small part of the whole stack in the Android that's running inside your phone or inside a tablet. Now, pretty much most of your day-to-day work is you are running on this layer. You don't interact with this part because this part is isolated. You can't see this part at all. It's just a bunch of binary that's running on your phone, right? But if you look at the source code, there's 98% of what's running is basically this part over here. Now, I'll go through these layers. Now, I'm not going to go into detail of this layer, but I just want to give you an idea of what does this layer do to your application and how does your application communicate with the layers and things like that. Now, in the application side, most of you are writing a Java application. There are sometimes you will require to write a native code, which I mean is by C or C++ code. So most of the time will be a Java code. So this is the one that you're writing, right? This Java API framework, this is the framework, this is the layer that we can say 100% of the time your application will talk to. So if you write, if you call, like, say, for example, if you write, if you use an OK HTTP library, for example, that will communicate with the network library. And that network library is actually part of this Java API framework, right? So you don't communicate directly here, but you communicate directly here. So it's not like you can jump over here, you cannot do that. So you jump over here. So this layer over here isolate what all these layers down here provides the Android operating system. So you as an application developer, you just have to worry about, okay, what are the API that I can call, that I can use, right? That's why internally there's a lot more API that's available for the system application, but for your application, there's only a subset of those API, and those API is something that you can look at in the Android documentation. Those are the API that's made public. It's not a private API. Most of the private API that's available for the system application are basically off limit. Only if you're writing a system application, then only you can use those API. Now that API, the Java API framework itself, rely on the native C and C++ library, regardless of what application language you're using. At the bottom part of the stack is always the native code, which is the C, C++. There's no assembler. There's only C and C++ basically. So this native C, C++ library is a bunch of open source project that is made available, that is being used inside Android. Because Android itself rely heavily on a lot of open source project out there that is made available in the Linux world. So if you've been using Windows, there's not a lot of Windows operating open source project that's being used. But if you're using Linux desktop environment for quite some time, those packages, those library that's available are being used inside here also. Of course, in a stripped down version because it's running in a in a very small hardware. So it's a stripped down version of that basically. This Android runtime is the runtime that is running your application, or this is the ART, the Android runtime. So your application is written in Java, that will be converted into a bytecode, and that bytecode is basically ran inside the device by this guy over here, the Android runtime. This hardware abstraction layer is the layer that talks to your hardware. So if you have Bluetooth, you have Wi-Fi, you have GPS, all these kind of things, they are the one that's, this hardware layer is the one that is responsible to provide that functionality of the hardware to the upper layer, and that hardware abstraction layer is the one that communicates with the Linux kernel. The Linux kernel is the lowest part of the stack, where it's basically is the raw part of the whole stack that communicate directly to the hardware itself. Now, what's interesting in the hardware abstraction layer is if you have phone from different vendors, you will sometimes see a different kind of what do you call it, behavior. So for example, sometimes like my phone, I'm using a Motorola phone. If I use a GPS for some time, all of a sudden the 4G doesn't work. Why is that? Well, it's just because this part over here, for some reason, is not working properly. So sometimes I need to reboot my phone so that I can use the 4G properly again. That's just for one example. So you will find this kind of different behavior with hardware. Sometimes the Bluetooth works properly in this phone, but sometimes the Bluetooth doesn't work properly on that phone. So this part over here is what the critical part is creating problem most of the time, because different vendors come up with different kind of phone using different kind of chips or different kind of IC from different vendors itself. So that create a lot of complexity inside, and this part over here, where most of the thing doesn't work properly, if it does not work properly. Okay, so that is the Android architecture. That's the Android architecture itself in a nutshell. Now, to simplify things, is the bigger thing is there's only three major layer, which is your application. The framework is the whole thing, and then the Linux kernel. So the framework is where developer like myself works on. So not only we work on the system application on the application side also, but we work on this framework part also. So pretty much we have to deal with all these kind of things on a day-to-day basis. We do touch sometimes on the Linux kernel, but that's something that we try to stay out of it. But the framework part is where where you can customize a lot of things. This is where gets Android into an interesting space where you can create new kind of a product. For example, if you come up with the idea of some product itself, you just customize the framework and then you come up with something new. That's why they can come up with Android Auto, they can come up with the wearable, the Android Wear, they can come up with the Android TV. So many things that you can really come up with as a product if you can master this framework part, and then you can customize that what you need depending on your need, right? So we will look later on what does this inside the source code. When I go through the source code itself, I'll show you which part, where in the source code this part resides in. So this is just something that to show you the complexity. When I show you the framework part itself, that's basically a combination of this different kind of source code inside. So you have this is based on Android. If I'm not mistaken, I took this data based on Android Lollipop, not on the latest one, not on Oreo. Oreo will be much bigger than this one, but I think it's based on Lollipop. But basically, pretty much what it says over here is all these different project or different folders inside the Android Android source code. Pretty much external framework is the one that is that occupy the majority of the source code. External is basically contained of all the different runtime library, the one that I mentioned about. They're using a lot of open source library that's in the Linux world. So this is where it resides. That's why it's so big, because you're using a lot of different kind of open source project. Framework is where the majority of the APIs are made available to the application. So it contains a lot of different kind of things inside framework. May that be from the communication to the hardware, or may there be an API that is provided to you as the developer. So this is where the majority of the code resides also. So when I mentioned about previously in the previous slide about the framework itself, this is how big the framework sometimes gets to. And with every version of Android, it gets bigger and bigger. But doesn't mean that this is something that you will work on. But majority of the time, this is how big you have to work on if you are working in on the customizing on Android. The amount of source code that you have to understand to know the whole picture, to get a pretty good idea about it. Now, these are some of the resources that you can look at if you want to get into much deeper than what this presentation is providing you. So I'll be uploading this slide later on after the presentation, so you can look at the resources. But the second one is the one that I've created myself. This contains a lot of description of the different folders of the Android source code. I've been slacking in maintaining that, but hopefully when time permits, I will update that more and more. But it gives you an idea, a sense of how the whole Android source code is all about. And then the other one is the forum from XDF developers. This is a very good resource if you want to learn more internally about the Android itself. There's a lot of content there that you can learn from it. Now, what I'm going to do is I've completed the presentation. I'm going to go more into the source code itself now. I want to do a bit of practical so that you get an idea of the whole thing. It's easier to show you the code rather than show you presentation. Can you see my screen? Okay. So what I'm showing you right now is this is the master, the master branch of Android, of the Android open source project. Now the master branch is an evolving branch. It keep on evolving. So every time when Google release the new version, say for example in this case Android P later on, O is Oreo, so the next one will be P. Then they will branch off to a different kind of branch basically. But master is the one that they keep on evolving, they keep on changing, and sometimes it works, sometimes it doesn't work, and things like that. But in this case, I just want to show you the master branch. So here the different folder. At the hindsight, you can see there are a few folders inside here, and I'll go through the to the different folder itself to give you an idea of what does each folders contain, right? Now, before that, I will just want to focus on the one that most of the developer will need to focus on, so that you don't have to spend a lot of time looking at the different folder and say wondering, oh, where do I get this, where do I get that, or where do I go to learn all these kind of things, right? So I just focus on the one that you will get benefit from. Now, the developers, the developer folders contain quite a number of sample application. Now, this sample application is an application that you can. Let me try to zoom there. Is it better? Okay. Is this better or this one better? Huh? Okay.
That's fine.
Okay. Yes, it doesn't zoom on the text itself. Sorry. Okay. Um, yeah. So sorry. So the samples Android contain a lot of sample application. Now this sample application is very useful because it shows you also some best practices that normally they use internally in Android also, and also how they use to develop their own Google's own application. So there's quite a number of applications that you can look at, and pretty much there are quite a number of applications that sometimes you cannot find examples and things like that on how to use the API. They do provide those kind of examples inside. So that's the developer. That's one of the folders. The development part, in the apps section, sorry, in the apps folders, there are a number of. This is not kind of a sample that you will use, but sometimes when there's a new API that's available in the, for example, like in the Android P later on, then you will see some kind of some example here to use that API, right? Or maybe sometimes when you see, there's a bug and things like that. How do they use this new API, for example? Because there's a changes in this API. So this is where they provide this kind of example, basically. Now, the problem is this example is not available. It is available as its own, so you can just check out these development folders. But I'm not going to go through that. But you can look at you can look around in the source.android.com. They do provide how to just check out a particular kind of project, so that you can just check out that, not project, sorry, yeah, project, that like develop folder, the whole develop folder you can download, and then you can take a look rather than you download the whole. The other one is where I find very interesting is in the packages, because remember Android also on its own has got its own application. So if you use how sometimes you use the system application, sorry, the settings application to turn on Wi-Fi, to turn on the GPS and things like that. That is an application on its own, and that is actually inside here, the packages, apps. Inside here, there is a folder called settings. Here, this is sorry. This is the application, settings application that normally you use to turn on Wi-Fi, turn on Bluetooth, pair with Bluetooth, all this kind of thing inside here, right? But besides setting, there's a lot more example that you can really use. For example, if you want to look at how to use a USB drive, how to read the USB drive and things like that, or how to use or how to create a sound recording app and things like that. There's a lot of example here that you can use. Or you want to create your own phone application, because you can create your own phone application to replace the stock standard dialer, for example. Then you have, like, for example, for this one, it's available for you to use it. Or if you want to use how to use NFC, it is available to use NFC over there also. So there are some application which is useful, not only in the sense that it show you to use the API, but there's a lot of best practices that you can get by looking at this application itself. And the best part is this application, some of the applications are quite complex, so you can really learn how they structure complex applications like Android. For example, Launcher is the application that you use on the device where you want to launch an application. So when you tap on an application, for example, you tap on YouTube, that is basically that icon live in Launcher. That is actually an application on its own, and this launcher here is that application basically. So there are a number of application there that you can take a look, and there's a lot of benefit for you to look at also. Okay, so the other thing I'm going to go through is I want to show you, there's so many source code inside Android, right? So how does it compress all this source code, so many source code, into the device itself? Now, when you compile Android, it's squeeze itself into a few files only, and those files I will show you the files now. Okay, so what I'm showing you is the final product after compiling Android into several files, right? Now, the files that is being used, that is going to be put inside your device, is called an image file. Now, this image file contain there are a few numbers of image file. One of them is called the system image. This file over here, which is 2.7 gigabyte. In this case, it varies, right? It's not the exact number, but it varies. But this is the system file. This is the files that is going to be used inside your device to run the Android itself, right? That's one of the system files. So that's one of the image files. The other one is the remdisk.image. That's one of the files, and the other one is the user data.image, which contain the user data. So when you when you store your data, that is where it will put your data into. So that's the initial. This is the initial part of the data partition, or the data, or the SD card, or whatever it is that you're using, that will be used inside your device itself. So after so many gigabytes of source code, that will be squeezed into few files, and that few files will be pushed into your device, and that is what is going to power your Android itself. Now, what I'm going to show you now is the different folders like the master. Art, this folder contains all these, the runtime that was mentioning previously. Your application will be converted to bytecode, and then that bytecode will be run by Art. Previously it was called Dalvik. They still have Dalvik, but now they're using Art. Bionic is pretty much the core library that is used in the low level, in the C and C++ level inside Android. So that's a stripped down version of what normally run in a Linux environment. It's a stripped down version of the library that normally run in the Linux environment. Is called Bionic inside Android. Boot table is got to do with the booting process of the device. So if you power on your phone for the first time, it has got the boot animation. You see fancy boot animation. Then after that, there's a lot of process behind the scene. Then it comes into Android. So this boot table folder contains a lot of boot table source code inside. The build folder contains pretty much all the build script. So in order for you to compile Android, it requires a lot of scripts. Because of the complexity of the source code itself, there's a lot of build script that needs to be written for different components that run inside Android. Just to give an idea, to compile Android itself on its own, it will take, on my laptop, for example, just to give you an idea, from scratch, it will take me 5 hours, approximately between 4 to 5 hours. And that's because there's a lot of build script inside that needs to manage all these different components together so that it can build together into that 5 or 6 image file when it's completed. So it takes a long time for you to build that. That's from scratch, but there is a way to speed things up, but the majority of the time, that's how long it will take. Compatibility contains, this folder contains about, this for testing purposes. There's not much use for most of the time for developer like myself. CTS is also is called the testing suite. That's basically if you're changing anything inside the framework, you want to test, and then you have to pass the certification process from Google, then you have to make sure that the CTS is passed also. So it's like a test suite for the framework, basically. Dalvik is something which is not being used anymore in the new version of Android. Developers development, this is something that we have gone through. Device, this contains device specific. So if you have a Motorola or LG or Huawei or even any kind of a device that you own, that information is pretty much inside this folder itself. So you have a lot of properties, a lot of XML files, a lot of text files, a lot of probably very specific vendor specific files that is contained inside here. External, this is the one that I was showing in the pie chart that contains most of the open source project. So it has got everything there inside. Framework is the one that most of the time that is being updated by Google, because that is what impact that will have most of the impact to the developers. So if there are any changes, any bugs or anything like that, this is where normally they make changes into. Hardware is the hardware layer abstraction that I was showing you, that when you have different kind of behavior because of different from different vendor, because of different chipset and things like that. Kernel is the Linux kernel, is the bottom layer that I'm showing you in the Android architecture slides. That's the bottom layer itself. I tried to skip some of the folders because things like libcore, libnative is something that you will not be interested in or will not be relevant to you. Packages is the one that I'm mentioning about. This is something very important for you guys that you can take a look at. From all these different one, PDK, platform testing, pre-build. Pre-build is one of the things that is pretty much used for, that contains the binary to compile Android, because sometimes Android, not sometimes, but most of the time Android will require a separate compiler to compile itself. So this is where it will contain. SDK is not the SDK that we are used to, the Android SDK. That's just part of it, but it's not most of the SDK that you normally use. It's a different kind of SDK inside Android itself. System folder contain a lot of system application. So not only you see settings application that communicate to the hardware, there are a lot of system application that runs behind the scene to make sure that the device runs properly, like power management, for example, or you have a battery to check the battery level and things like that. That will contain inside here the system itself. All right. So sorry if I'm speeding things up because I'm looking at the time at the moment. So what I'm going to show you is now is just to show you how it runs on my laptop if I compile all these things. Now I've already compiled. I've compiled the master branch, so I can run it on my machine. So I'm going to show you how it looks like on my machine after it's being compiled. Sorry, this. So what I'm running now. So this is the latest master branch from the operating system. So it is running. So there you go. And I starting. So if I look at the settings itself, this is where normally we will see information regarding the version of Android and things like that. So I go to systems. So I'm running this queue. So forget about P is now going to Q now in the master branch. So, and the model is the emulator because it's running in the emulator environment. This is the same kind of emulator that you use when you write your application and you want to test on your machine rather than on a device. So this is kind of emulator. And then it's running the kernel 4.4, not the latest and greatest, but should be fine. And this is the build number. This is built on my machine basically. Now, this is the same kind of emulator that you use when you develop the application. So to give you an idea, let me connect to this emulator so that I can run an application inside here. So pretty much this is like a full functional Android, right? So you can do anything you want. You can do, of course, not all the hardware functionality is available, like camera and things like that. But for your normal like network communication application or video or something like that, you can use this emulator, for example, to test your application. So just give me a second. Let me connect to this emulator, and then we're going to run an application from Android Studio. So let me just connect first. Sorry, let me just rerun again. Alright, so what I'm going to do is just a very simple application to test. So I'm going to run this, and then it will show up over here. So there's a test application. So as you can see, it works like normal emulator. So what I've done is basically I've taken the source code, I've compiled that, the Android source code, I've made my own emulator, and then now I can run my application inside my own emulator. So the whole thing is basically my own, basically. So I can do now whatever I want with the Android itself, and then I can change this, change that, and do whatever I want, and then run my application on it. So pretty much now I'm a stage. I can say that, okay, look, I have this idea. I want to run this idea. I want to change Android into this kind of product and things like that. So this is what you can do basically with the Android operating system, basically, right? So that's the emulator itself. Now, do we still have time?
Yeah.
Okay, so if we have time, then I want to show you something cool, something interesting. I want to show you how to change something inside this emulator, right? So what I'm going to do is, if you look at this, have this Android showing here. So what I'm going to do is I'm going to change that into a different kind of image, basically, to give you an idea what the process looks like. Okay. So what I have here is the configuration file that I previously changed. So I'm going to change that configuration file so that it picks up a different kind of image. So when it compiles the operating system again, it'll pick up that image and then we use that as the boot animation, basically. So once I made the changes, what I'm going to do now is I'm going to compile it. So this will take 2-3 minutes, less than that. So what it's doing right now is I'm instructing, excuse me, I'm using the make command. I've done previous steps, a few previous steps before I reach to the make command, but just to save time. But what I'm trying to do is here, I'm executing the make command, which is to compile the operating system together and put everything, all the packaging and everything together, so that I can run it as an emulator, right? So what he's saying here is this is the Q version of the platform itself, which is basically the Android version, and then it's just giving you some information about my laptop itself and what the architecture that I'm going to build. Remember, I was telling you that there are two different silicon vendor, whether it's ARM or Intel. So in this case, I'm building emulator which run on my laptop, which is an x86, right? So because of that, that's why it needs to, the architecture that is targeting is the x86 target. Now, yeah, that's basically the information that it's providing, and also the out folder is the out dir. So that's the directory where the output will be, basically, right? So that's where I was showing you where the image file will be stored, where all the different properties file have been generated by the by the compilation process itself. So yeah, so to give you an idea, if you want to compile Android or you want to play around with the Android itself, you require a bit of beefy hardware. The minimum is there's a minimum requirement that you can look in the reference in source.android.com, but pretty much what the requirement is, you need to have at least 16 gig of memory, And you cannot use normal hard disk because it's going to be very slow. You need to use SSD. SSD hard disk is the solid state drive, the hard disk basically. It's a big source code, so you need at least excuse me, 250 gigabyte or 500 gigabyte of hard disk. You need quite a powerful processor, not the beefy processor, but you can use i7 or i5. That should be fine. But if you want to speed up the process, then you need the latest and greatest processor if you can get your hands on. But other than that, the rest, like in terms of screen size and things like that, doesn't matter. What matters is the RAM, the hard disk, the processor. That's the main thing that is required to really run this properly, to compile properly. Excuse me. Now, because I'm not running from scratch, I'm just changing things here and there. Normally, it just takes between 1 minute, 2 minutes, to all the way to 5 to 7 minutes, right? But if you make a lot of changes here and there, then probably it's done. So like this case, it takes me 3 minutes now to build it. So now if I run this now, hopefully you will see something different in the. You see that? Are you able to see the board animation clearly? Yeah. Okay. All right. Yeah. So that's what I want to show you for the day today. So if there's any question or anything like that, feel free to ask me.
Okay, we think that after the emulator opened the last time, we are listening. Can you speak again now?
Sorry, I can't hear you properly.
After the last time you opened the emulator, we have been hearing a strange sound. Maybe if you turn off the emulator, the Android emulator.
You were not able to see it.
Basically, no, the thing is, when you start the emulator, the spike. Do you hear me?
Yeah, I can hear you.
Okay, so when you start the emulator, the big spike on CPU, your voice almost unrecognizable for a few seconds. So that's
okay.
We lost you a little bit.
Sorry about that. I didn't realize about that.
Okay, so that's it, Nanik?
Yeah. So if there's any question.
Yeah, let's start the questions. Mark?
Well, can you hear me here or no? Okay.
No.
So, I have a few questions. For instance, what tools are you using to add new code to the source?
Okay, that's a good question. I get the question a lot. Frankly speaking, the problem with the Android open source project is it's not something that you can use Android Studio out of the box directly, like how you normally write an application and then you can start writing the application, right? The problem is because there's a lot of different components. So most of the time I use mixture of Notepad kind of or Vim, like Vim kind of a environment, and also a mix of Android Studio, and also a mix of Eclipse. Now, the reason why I'm doing that is because I found that combination works for me. You will not be able to use Android Studio as a whole, as on its own. You cannot use that. That's for sure. I've tried that. It doesn't work at all. I've tried with Eclipse. It works, but it's not 100% functional. So what I normally do is I do the changes of the code changes inside Eclipse or Android Studio. Then I do the compilation outside, like how I was showing in the compilation itself. So the development life cycle for this is very long compared to normal Android development, just because the tool itself is not 100% correctly working and it's not provided by Google itself. So you need to find a way that works for you, basically.
Nice. Another question. When do you think that it's interesting to use our own image of Android?
That's a good question. The way I see it is like this: if you're thinking outside, let's look at this way. Android is not only an apps, right? From this today presentation, hopefully you can see that Android is beyond apps. There's a lot more than an app, than only an app itself. You can create your own product, may that be any kind of product that you can think of, or you can even design your own phone or your own tablet, whatever it is that you want to do, right? Now, for normal Android development, you will not use your own image unless, of course, you really want to understand how the whole thing works. Then, of course, you will do your own image. But under normal circumstances, under normal app development, you will not use your own image, right? But if you are thinking of getting into the stage where, okay, look, I want to go more than apps, then this is the right path for you, and this is the way that you have to go, basically.
And last question for my part. Kotlin is getting more and more popular nowadays. Do you think that it's possible to create system services or system apps with Kotlin?
You mean for the Android itself, or you're talking about outside apps?
I'm not thinking in anything in concrete.
Okay.
I mean, maybe for the system level apps, like for the, for example, for the contacts app, like the Android one, for example, you can build it using Kotlin, or for example, if you want a new service, or for example, I don't know, to access a device like a new device that uses a different protocol of Wi-Fi, for example, Wi-Fi. So it's possible to build a system service, for example, with Kotlin and compare it with, along with the source code.
Well, from my personal point of view, anything is possible, right? I mean, Google has already provided Kotlin to the developers, right? But what I'm saying is, most of the Android source code itself, they're not using Kotlin. They're using still the old Java syntax and things like that. So they are using a lot of the new code. They're using Java 8, basically the Java 8 syntax. But I won't be surprised if later on they're going to move to Kotlin, or even for that fact if they move to a different language. You don't know. I don't know. I can't comment too much on that. But in terms of whether it makes sense, yeah, it's possible also. It's not going to be the only solution, but we never know. It can change, it cannot change, I don't know. Yeah.
Okay. So, no questions?
I've got a question. How long does incremental compilation take? So for example, let's say that you modified a single line in the core. How long does it take to see the change?
Okay. Now, the changes that I made, there's just a configuration changes, right? So that normally when it's a configuration changes, or it's just like a copying of the file of the configuration, it won't take long. Like earlier, you were saying that it was taking me 3 minutes, right? Because I'm using on my laptop. Normally in my desktop, it'll take me only 30 seconds because it's a desktop environment, and also I have a more beefy processor also. Now, if you're changing, for example, the framework, let's take example the framework. If you're changing, even if you're adding a new API, and then that API you want to use it for your application. For example, you create a new service inside Android, and then that service is made available to application, right? Now, to make that service in the framework itself, when you compile it, it'll take longer because when you detect a change in the framework, it'll compile the whole thing again. And when you compile the whole thing, doesn't mean that it compile the whole operating system again, but it just compile the changes. But the incremental will be longer compared to if you change only a configuration. So any source code changes in the framework will take a bit longer compared to if you change only a configuration file for that matter.
Then in that case, in that particular case, probably you have to reboot the emulator again, no? Which also adds time to all this process.
That's correct. The whole life cycle, of somebody like myself to make changes to something is like get a coffee, drink the coffee halfway, and then you're done.
It reminds me, I don't know if you have developed on BlackBerry on the very first environment where you had to reboot the whole device like almost every time when developing an app. I mean, it's not that you are rebuilding the system, but it reminds me of this.
Yeah.
Para que los servidores también no estuvieran caídos.
So do you like, I guess that instead of trying to build the thing iteratively, you try to like get the thing right in the first place, and then you train. Wait for.
Sorry, I didn't get your question. Sorry.
Yeah, so I guess that instead of building the service or whatever you want to build iteratively, you do it like you write as much code as you can, then you compile and try to make it work.
The way that I normally do is like this. If I think that the app can be written in Android Studio as a normal Android app, I'll write that boilerplate code inside Android Studio first to make sure that it works, right? Then after I know that it works in Android Studio, then I move that into the Android operating system and then compile them together. Now, it doesn't mean that if I create, for example, if I create a service and if I use an internal API, I can use in Android Studio. I cannot do that, right? So it will create an error and things like that. But what I can do is I can create the non-system API first of the code inside Android Studio and make it work, and then convert that and put that into the Android operating system, and then start adding all the system API inside the code, and then test from there. Now that process will take longer compared to this process, but at least I've saved time rather than going all the way into the operating system itself.
Yeah, just out of curiosity, is the Android system code base unit tested?
Sorry?
Yeah, I was asking if the Android system code base is unit tested.
Oh yeah, it does. Remember, I was showing you the CTS, the compatibility test suite. They have that also. That means that what I mean is basically every time you want to release something, they have to go to a test suite. They have now also, because with the new version of Android, they have the vendor test suite also. So because of, I'm not sure whether you guys are familiar with the Project Treble.
Yeah.
Okay, so Project Treble is the one that to make sure that you down the track Android can run. If you build from the source code, you can use it in any kind of devices. That's basically the long-term goal is. So with the VTS, which is the vendor test suite, all the vendor need to pass that test suite in order for you to release the product. Because without passing that, then it's not possible for you to release the product.
That's public. I mean, because I haven't seen the Project Treble. Is it public? Is it in the public repositories of source code? Because I think Google usually what it does is they have their private repos, and then they have the public ones, no?
The way the Project Treble work is it provides you a layer of API, and those API are available inside the hardware folders. So if you look inside the hardware folder, there are specific specific library for Trebles. No, sorry, not library. Specific API for Treble also, but the Treble, the vendor binary files. The vendor binary file is not available. Of course, that's only available from the vendor itself. But the API layer is available inside the Android repository.
No question?
Thank you.
Thank you, Nanik.
Thank you.
We will hope to see you in the future.
For sure.
Okay, so bye.
Yeah.
Thank you. Bye-bye.